Thank you. Thank you very much. It's very nice to be here. It's my first time in the conference, and it's been super interesting this whole morning to hear more about Archicad and also actually see a lot of the cool stuff that is possible to do with Archicad. I will show you a little bit of what we are up to, the projects that we are doing, and then also a little bit of the concerns or the sort of research that we are up to. And as it was mentioned previously, we have not been working so much with Archicad, but now we're actually transitioning most of our processes to work with Archicad. Our office, we work with larger urban projects and then also smaller research projects and almost to the product level. And we do research, but then design, but then we also participate in constructing some of these prototypical projects. Well, here's our office. We are like about 15 people, about half Finnish, about half international, and we're located in the sort of a street level in Helsinki. You can see our office is right about there. Yes. And I'm going to first show you a couple projects, larger projects that we're doing, and then some of the research stuff that we're doing. We worked a long time. This is Helsinki Downtown. On this, there's a small bay inside the Helsinki city center, which is where the central park of Helsinki is connected to the Baltic Sea and to the urban fabric. So it's an extremely unique location. It's actually a location where there are most of the cultural icons of Finland are located as well. So libraries and Olympic stadiums and music halls and parliament houses and etc. But it's also in Finland a super controversial spot where all the way from Alvar Aalto there has been a lot of Eliel Saarinen and a lot of plans to transform this area. But despite of all this effort for the past 100 years, not much has happened. So we came up with this strategy of using this acupunctural idea of only changing small spots. And the challenge was that there's also this bay, because there's no much water flow. It's getting into quite bad condition. So we came up with the project where we could actually purify the whole water and create some new public spaces and public buildings. So it's a large intervention of about 50,000 square meters right in the heart of the city, creating new recreational places and public buildings and hotels, and then also some new restaurants. Besides that, larger urban interventions, like this is the second largest city in Helsinki, in Finland. We won a competition together with the Danish office Kobe to transform this whole rail yard area into a new urban area. It was actually a competition for designing a new station, but our proposal was, instead of just making a station, was to actually expand the whole city. So here you see the gap, the railway, in this figure ground plan, and this was our proposal. So 300,000 square meters of new space on top of the existing railway, creating a new urban facade in the city. So there is, we took down some of the new buildings, some of the old buildings, and created a new front and a new city center on top of the tracks. And then also, in addition to that, a new train station with platform levels and a public plaza on top of them, developing that. And more our office, we have been working with these urban projects. We have been working with also on the strategy of developing cities, like trying to understand, this is the old capital of Finland is Turku, work with the mayors and the city planning department to understand what is the identity of the city. And for us, that it means sometimes it goes from designing new public spaces to actually thinking about the whole traffic systems of the city. And in this case, we came up with the new master plan of nearly 200,000 square meters in the city center. But what I want to talk about to you today is much more about our sort of experimental work. Because, of course, when this city planning, it takes time and it sort of goes with its own pace. But another foot is very strongly on thinking about what the buildings will be in the future. And of course, technology has a great role in that. This is a nice image that I have to say I love this image. This is one of the first images taken from the globe, from the Apollo flights from the 60s. It's a moment when we understood that this is it. This is what we have. There aren't any spare parts. And actually, what happened was that it changed the completely way that we gradually started to understand what is the position of people and nature and the environment. And when we think about the future, like how much we're going to build in the coming decades, and what kind of future we're building, and what are the sort of technologies and the buildings and the architecture of the future, you get the kind of a sense that we are a little bit lost. And that if our goal is to get back on the track to consuming only one planet, construction industry has a huge sort of an effort that we need to make. It's not that we would be missing the technologies. We have all the technologies. We have 3D printing organs. We're going to Mars. We are granting citizenships to robots. So I would imagine that we could also rethink how the built environment works. But unfortunately, I think that this is a little bit how we, as construction industry, we react to these challenges. That we get scared, and then we come up with fast solutions. We try to apply technology on buildings without actually thinking what the buildings should be in reality. So there's a sort of in front of the crisis, we try to stay calm and just add a little layer of technology and try to get away with it. But in the end, the solutions are mostly like this. This is an eco car from the General Motors. So it's very super eco-friendly, but it's still the same pickup truck. So has anything changed? So the question is, can we fine-tune this solution, or should we actually think about it more profoundly? And I think that one of the fundamental reasons behind here is that this is a little bit how we see ourselves and how we make architecture and how we make buildings. This is a painting from the 19th century. So we are the sort of conquering the world and being superior to it. Whereas in fact, this is how we are at the moment. We are very deeply in the situation where we need to rethink what the environment will be in the future. And of course, the question is, how does that translate into the architecture, into the expression of architecture, into the language of architecture? Many of the buildings that we still make today, they root into the thinking of the past century. And if we think about what was the world back then, what were the technologies, what was the invention of the whole modern architecture, how was the society back then, and what were the visions of that? One could say that not much of that has changed. Or many of the visions have changed in the back, but not the built environment. So that means that still this radical diagram from the beginning of the past century is still sort of a model of the most of the environment and architecture that we are making. And we have to ask that is this something that we know that will be a better future? So what we are interested in is in thinking that if the built environment is, of course, a crucial component of our culture and our built culture, is that what would be the built environment that would actually sort of take into account also the environment? So how would the architecture change? And I think that this is for all of us, whether we are architects or engineers, this is an interesting point. This is usually, if we think about the sort of building systems, or the systems that we have in the buildings, that translate into these kind of things and these kind of things. This is from the Biennale of a couple years back. This is a room where architects usually operate. So there's a hell of a lot of things happening where we don't have anything to say to. And it's funny that this is where we deal with. We might flirt a little bit with the structure, but anything else that we have in the buildings don't actually affect in the architectural expression. And it's interesting that if we think of any other things outside of the built environment, they have all of these included. If you think about, for example, ourselves, how we are. I mean, we can't kind of separate the the nervous systems or the circular system or even the brain system. It's all interconnected. The beauty of the system is the sort of the system itself, all these things working together. And we can find, if we think about where we can find these examples in nature. Why is a tree beautiful? Why is a forest beautiful? Everything in every level is actually working together. The information, the flow, and everything, they work together, and actually they are the ones, even the cellular level, that's how things become beautiful. And that's why what we have started to, we did a project just actually completed a couple weeks ago in the Venice Biennale, where we investigated the relationship between the structure and its environment, and how actually they can work together. So we worked with the carbon dioxide levels and the structure using humidity and temperature and daylighting as sort of variables in the equation. We got the opportunity to make an installation to the world-famous pavilion by Sverre Fehn, which is actually representing itself quite well, this thinking. What's the sort of a relationship between nature and the built environment? So usually we're very used to working with wood, but we said that in this case we need to work with something different. So we wanted to work with air and water as primary structural elements, and actually create something that works together with its environment. So we designed these systems together with Buro Happold, Berlin, and then Pneumocell from Austria, and actually created these sort of cellular structures that work together with the environment. And of course, first, as it was shown in the previous, we made models, and then we started to see how it actually works. But then, in the end, it was a huge process of actually creating something with water and with air. And of course, a lot of algorithms, a lot of in-between going with different softwares, and actually understanding how can you use pressure and how can you use water as sort of a main component. And I must say, it was really a learning process for all of us, all the engineers, all the manufacturers, all the architects, everybody working together with different softwares, understanding how the fabrics and how these things work. And then in the end, we fabricated these relatively large systems and took them to Venice and assembled them in a couple days. And of course, in order to make this possible, so what we have in each of these systems is that we have 18 smaller bubbles that are all controlled with 3 computers that work with the sensors that are in this space, and then actually these things, they breathe inside. So we built these custom-made computers behind it, and actually the end result was that these sensors in the space, they react to the carbon dioxide levels, and they send input to the computers, and then they make these cellular systems breathe in the space. So they work with the environment, they get their shape, and they actually get their colors all from the environment. So when it gets colder, they change the color, they become more reddish, and et cetera, et cetera. But of course, this is an installation. And the other research project that I wanted to show you deals with working with the built-in environment with engineers, and actually trying to understand what we could do more together. In Finland, we have this situation that about 80% of the country is covered with forest. So you could say that by default, it's a quite sustainable country. But of course, the reality is that 40% of all the emissions and energy consumption is actually coming from the built environment. And as said, this is how we still build today, whereas we also, like in Germany, we make a lot of cars nowadays as well, and this is how we make cars. And we have to think about how we can actually transform this whole system into something different. About 1% is the research and development rate that at the moment, there is at the building industry. And if we think this in sort of a larger terms, it's hard to imagine how we could actually change things into something different. If we compare it with any other industry. For example, I love this example because it's a vacuum cleaner, and they spent, what, 200 engineers, 16 years developing this vacuum cleaner. And I always wonder if we could have the same resources to develop even one building. What could it be? What kind of a system could that be? So we work very closely. This is from Aalto University. We started a research project studying new kind of timber structures. And we came up with this multidisciplinary group an idea of using only 18 millimeter thin plywood structures and create this experimental structure in China. And this is how we tested the first one. This is the architects making engineering. So it was a nice idea, but in the end it didn't work at all. So this is now our architect and the engineers giving some feedback from the model. But in the end, we made a lot of testing and made a lot of one-to-one prototyping and actually came up with this quite interesting structural system that is beautiful at the same time. And it was super hard to any of the engineers to actually calculate it. So we ended up making these one-to-one models and then testing it again, and this time actually it stand. And then we put it all in this one small box, actually, and took it to China and made this about 100 square meters structure. And then took it to the Central Park in Shanghai. As a kind of a sort of a wrapping up project that I'm showing to you that combines sort of elements of these research projects and some of the other public buildings that we have been designing is related to education and then also new structural systems. A couple years ago, we started this reform or this change in Finland about rethinking what the schools should be. Finland is famous for its schools, but of course the times are changing, so we need to rethink what are the actual typologies of the school buildings. We know that the life and the working has changed a lot, but actually the architecture of the schools have not changed so much. There was a decision to transform from a subject-based learning into a phenomenon-based learning in Finland, which means that there's no longer just mathematics or geography or history, but it's all combined. So say you study climate change, or some larger, more complex issue, that then you can use different subjects to investigate a larger problem. And that means that also the schools, they change a lot. So we also have been thinking like a lot of what are these new sort of public buildings that combine also then the public domain in a completely different way, people who use the school and also people outside of it, and how they become sort of a more like public libraries or open spaces where different groups work individually and in smaller groups and larger groups. And then also they contain spaces that are more like laboratories where you can actually investigate the, how would I say, the environment or these more complex issues in a new manner. This is one of the projects, a competition we did in Helsinki. A similar thing, we have been working a lot with museums. This is, unfortunately, didn't win this, got a second prize in the art museum competition in Finland. But trying to basically understand what learning could be. And we did this for a long time. And then we figured that, what are we doing all these competitions all the time and just trying to push that we should also try to combine some of the work that we have been doing. So we started again this research project together with some institutions in Finland, with the university and the technology funds, trying to rethink what could be a sort of a new kind of a building typology of the school, of this new school in Finland. And of course this involves making prototypes and understanding, because we wanted the structural system also to be something that is innovative. So we used this idea again of building prototypes and creating larger structures. And we actually started to use this idea that Toyota uses in their thinking, so that we focus on actually bringing the best knowledge together and trying to understand what we are actually doing. Like it was mentioned also here in the GRAPHISOFT presentations. We try to understand what are the larger questions behind it. And actually the right results will emerge from that. And we have a history of studying these structural, or this wooden dome structural systems. This is a Zollinger structure, a project we did in Finland a couple of years ago, together with some students from Columbia University, New York, and Oulu University in Finland. We did this, structure that has actually used straight wood beams that all connect in the center. So this has about 500 unique pieces that all interlink in the middle. So of course, the joinery and everything had to be done with algorithms and scripting. But it's actually an interesting old structure that that was invented in Germany in the 1920s. This is one of the barn houses that was made in 1926 using the same structural system. So basically what we did with some engineers from Ramboll was that we refined the joinery and actually scaled it up, and then came up with an idea of how to create this sort of a school building that could be changed from the inside also as the school system is changing. So basically using quite simple components inside, but then cladding it with this actually relatively cheap structure on top of it in the end. So this is about 6,500 square meter structure. So from this, going into this. And actually, things were going super well. We got a project like this, 6,500 square meter, but then the municipality that commissioned us, we won the competition, they got scared. They said, no, come on, it's a school. This is not a school, this is something else. So it was like, half of these people said, yes, we're going to the future, let's do this, and these guys said no. And in the end, there was one more guy on this side, so they said, let's not do it. So we said, okay, we will continue it. But we got a new client, or actually not a client, but at a site, but from a very different city. From a city in the States, in the middle of the desert in Nevada, which is the Burning Man Festival, which is about 70,000 people gathering every year and creating a temporal city, which is actually focused on experimentation. And actually most of these buildings are made with wood, and of course we know what happens in the Burning Man in the end. So we had a group of about 100 people from Finland, university professors and artists and scientists, and everybody gathering to our office during 1 year, every week, thinking about this project and thinking about how they could collaborate and what kind of nice things we could come up with. So we manufactured everything in Finland, shipped it to US, and then started the construction there. And in about 3-4 days, we actually created this first learning space in the desert in Nevada. And of course, this is a small building, about 200 square meters, but yet constructing in the conditions of about 40 degrees Celsius. It was quite intense. We also collaborated with the space group that actually created this antenna that then we got some light, we got some signals from space that were then transformed into light and sound art installations inside this space. But actually, this is how we started. Day 1, then day 2 and 3, then day 4, day 5, the final party, and then day 5 was burning it, which was the crazy part. I must say, I have never felt so mixed, I have never had so mixed feelings when working for 1 year into a building with all this trouble and a lot of, I can tell you, financial efforts as well to make this possible. And then after 5 days, what happens is this. So, and I can tell you, we have a lot of discussion about wood buildings at the moment, that how well they burn or not. They don't burn very well. So this took a lot of time to get it down, actually. But in half an hour or so, it came down. But what we had to do is that we actually had to mechanically destroy most of these arches, because otherwise it would have not come down at all. So, but that's what happened, and this was the day 6 then. This was all that was left from this experimentation of us. But luckily, it was not for nothing After this, we have now starting this summer the construction of the first sort of a prototypic kindergarten in Finland. And what we have noticed throughout these sort of projects that we have been up to is that, of course, when we want to do projects like this, it's quite hard to find clients. It's quite hard to find, well, of course, if you burn them, that's quite hard. But even if you don't, to build these sort of an experimental structures. So what we have actually done is that we have also shifted the role of the architect in the project. So we have figured out that once we take more responsibility of the whole itself, so figure out the cost, figure out the structural system, and actually participate in the whole sort of a producing of the building, that this will actually open up quite great new possibilities for architecture. This also allows the sort of a quite free transformation of information inside the design and construction team. So what we did is that we have hired engineers to work. We are an office of 15 people, but still we have engineers who work with us, who script, who do programming, and who actually then, we have a completely different way of discussing with the clients as well. This is, I must say that what was said this morning about, and also in the previous presentation by Michael about the sort of a feedback loop between Rhino and Archicad. That was for us the pivotal moment when we said that we can actually transform our all, or actually start using Archicad in total. Before that, we were sort of hesitating, to be honest, but because the Rhino input was so crucial for us. What we need, we do a lot of, what we do in order to make this is a lot of programming, and a lot of using Grasshopper, but also links and creating different sort of program particles inside the Grasshopper. So that's why we need these kind of things. But maybe just to end this presentation, I want to add into this, because this is like, we talk about technology today. We talk about how architects can do things differently. We know that about less than 5% of the global buildings are designed by architects. And I think that if we want to make this shift of actually transforming the environment into something different, we also need to think about how to organize ourselves in a completely different manner. I'm not saying we need to become shoemakers, but I'm just saying that maybe there will be in the future even quite crucial sort of transformations in our industry, so that we're able to tackle these things. And I think that we need to sort of remember what's crucial in architecture in the end. Of course, it's always personal, but it's something that we are responsible of adding the value and also being responsible of the things that are sometimes invisible. And even though we deal with a lot of technology, and we see technology as something and the tools today, I love this quote by Adolf Loos, and I think we need to remember this when using all the technologies, that in the end, it's not about technology. It is about, actually, architecture is about thinking. It's about bringing abstract things and transforming abstract thinking into physical objects. Thank you very much.
Thanks very much.